going to start with the question 9. Okay, so question 9 leads to say three cables are connected at A. Okay, three cables are connected at A. Okay, where the forces P and Q are applied as shown. Okay, at point A we have two forces that have been applied on. We have force P and the force Q. Okay, knowing that force Q is equal to 0, therefore find the value of P, for which the tension in cable AD is what? 30305 Newton. So for this question in statistics, this question carries about 25 marks. Okay, this question carries about 25 marks. Okay, so you are advised when you answer in this question, and don't go through my shortcuts. Okay, you have to show the whole procedure, the whole methods. Okay, because in instance of mark steps, some steps, it doesn't mark only the final answer, it also marks some more steps. Okay, so for now, let me draw a rough diagram for this one, for this question. Okay. 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 So you can draw a rough diagram, sharp, sharp. All right. So guys, we can start solving now. Okay. So this is a rough diagram of this question. Okay. So the first procedure that we're going to take is for us to identify the points. Okay. It's for us to identify the what? See? The points. Okay. we're going to identify the points in the form that each and every point is going to have the coordinates in the x, y, and in the z, okay? So we're going to start with point A, okay? We're going to start with point A, okay? So for point A, we're going to identify the distance it has moved in the x, in the y, and in the z, okay? So for point X, for point A, okay? Point A is this one. The x-axis is this one. That one is the y-axis, and this one is the z-axis, okay? All right. Okay. So as you can see, point A, it is this point, okay? Point A, it is this point. Now we're going to identify, okay? At what distance is point A moving in the x-axis, okay? What distance is point A moving in the x-axis? So for point A, it is this point. The x-axis, it is this line. So you have to identify the distance point A has moved in the x. So as you can see, point A has moved a distance of 960 millimeter. So these are positive values of x-axis. If it was that side, we would have put a negative. So for this case, it's going to be positive, positive 960, okay? Positive 960 I. That is for the x, okay? Apart from finding the distance in the x, we are also going to find the distance in the y for point A, okay? As point A moved a distance in the y, as point A moved a distance in the y, you can check in your diagrams. As point A moved the distance in the y. So the y, it is this line. As point A moved the distance in the y. So I did not put the distance here. It was supposed to be, sorry, 240. Exactly. Point A has moved a distance in the y, and the distance is 240 millimeter, positive 240 millimeter. So it's going to be positive 240 ij. So it's going to be j. J represents the y, okay? Apart from finding out that, we're also going to identify as point A moved a distance in the z. Z, what I mean, it has moved either this side or that side. So for this point, point A, as you can see, it only moved in the X and in the Y. In the Z, it did not move. So it's going to be 0 K millimeters exactly. Okay? Any questions so far? Anyone with a question? How to find the points? Okay, no question. So we go to point B, same procedure. We're going to identify the coordinates in the X, Y, and Z. So for point B, it is this point, okay? Point B, it is A. What is the distance of point B in the X? What is the distance of point B in the X? The distance of point B in the X. So point B, it is this point. And the x-axis, it's either this side or that side, okay? So for point B, in the x, they're moving in a, so it is going to be 0. Point B, it only moved in the z-axis, okay? The z-axis. But for the x-axis, point B did not move. So it's going to be 0i, okay? That is for point B in the x. What of in the y? Point B, what is point B? What is the distance of point B in the y? So the distance of point B in the y is also 0. The y-axis, it is this line, meaning point B has moved either this side or that side. But now for this case, point B did not move either up or down. It is just lying in the z-axis. So it's also going to be plus 0j, okay? That is for point B in the x and y. What of point B in the z-axis? So for point B in the z-axis, it has moved this distance, a distance of 390 millimeters. So it's going to be positive 390 K millimeters. Or supposed to be 380, huh? All right. 380. All right. Okay. 380 millimeter. Exactly. So that's how we correct the points. Okay. So from point B, now we go to point C. Okay. Same steps. We identify the distance of point C in the X, Y, and Z. So for point C, it only moved in the Z axis. Okay? It only moved in the Z axis a distance of what? 320. But now for this case, the positive values of Z are this side. So this one are negative values of Z. So in the Y, the not move, it's going to be 0 plus 0J minus C 320 K millimeters. Okay. Any question? Anyone who's behind? Okay. No question. Okay. Now we go to point D. The same procedure. We identify the distance in the X. So the X-axis, it is this line. So point D did not move in the X. Okay. So for point D, in the X is going to be 0I. Okay. What of in the Y? What is the distance of point D in the Y? What is the distance of point D in the Y? In the Y, mean there's supposed to be a distance from that side D to that side. There's supposed to be a distance. What is that distance? 960 exactly. So it's going to be positive or negative? Exactly. It's going to be positive. 960 J. Okay. What of in the Z? As point D moved in the Z axis. Huh? What distance? Exactly. So as you can see, point D, it is this point. It has moved this distance. It is even shown, okay? So the Z-axis, it is this line. So it has moved a distance of 220, this distance of 220. But now for this case, it's going to be negative 220 because these are negative values. So it's going to be negative 220 K millimeters, just like that, okay? Right. Okay. So the next step is for us to find position vectors. Position vectors. Okay. So when talk about position vectors, these are vectors directed from one point to the other. Okay. Position vectors are vectors directed from one point to where? To the other. Okay. So for this case, as you can see, the question is saying 3 cables are connected at A. So A means more like the center. Okay. The center of the cables. There's a cable going this side, that side, and this side. Okay. So we'll be moving from A to a certain point, from A to a certain what? Point. So you can start with any position vector. You can start with position vector AB. You can start with AC or AD, depending on what you want. So for this case, I'm preferring AB. Okay. Position vector RAB, which is equal to B minus A. Okay, which is going to be B minus C. We're going to subtract the points from B and A. Okay, so I mean we're going to subtract B from A, which is equal to RAB is equal to B minus C. What is 0 minus 960? Negative 960 I, okay? 0 minus 240, negative 240 J, okay? 380 minus 0, that is 380 K millimeter, okay? That is the position vector of RAB. Any question? Anyone who is behind? Okay, so apart from writing the position vector, we are also going to find the magnitude of the position vector. This magnitude is going to help us find the unit vector. Okay? So we're going to find the magnitudes of AB. Okay? The magnitude of AB is equal to position vector AB of S. Let us find the magnitude of AB. It is 960 squared plus 240 squared plus 380 squared. Okay? Anyone to punch for me? The magnitude of AB. Okay? 1000 D. What's it? Like this? 1000 D. Like this? All right. 1060 millimeters. Okay? Okay. That is the magnitude of RAB. Okay? Apart from finding the magnitude, we're also going to find the unit vector of AB. Okay? We're also going to find the unit vector of AB. Okay? When we talk about the unit vector of AB, how do we find the unit vector of AB? We're going to find the position vector of AB over the magnitude of AB, which is equal to negative 960 I over the magnitude, which is 1060, okay? Minus 240 over 1060 J, okay? Plus 380 over 1060 K. That is the position vector of AB. That's how you find the position vector of AB. Okay? So for this case, as you can see, there are no forces given in here. There are no forces given in AB. Okay? For now, we're just going to express this force as a Cartesian coordinate. How do we express force AB as a Cartesian coordinate? By multiplying with a unit vector. Okay? Force AB is equal to force AB multiplied with the unit vector AB, okay? Which is equal to force AB multiplied with unit vector AB. You can divide for me these numbers. Negative 960 over 1060. And negative 960 over 1060. 0.9056, okay? I minus 240 over 1060, 0.226 J, okay? Plus 380 over 1060, 0.3580. All right, IJK. It's exactly. That is our force AB. So we are done with one force. You can copy so that we do the other one. Okay? Anyone with a question so far? Right. So I would advise you to follow this procedure because this procedure guarantees to get 25 marks out of 25 marks. Because there are some procedures that you are missing some steps, okay? And you might end up getting 17 out of 25 instead of getting the whole stars, okay? So make sure you show the steps, okay? Distance of fusion marks the steps instead of the final answer, okay? Right. Okay, I've got, okay. Let's So now we go to the other position vector, which is we did AB. Now we go to AC, position vector AC. So it's going to be our AC, which is equal to C minus A. Our AC, which is C minus A. So I'm going to subtract C and A, okay? What is 0 minus 960? Negative 960 I, okay? C minus A. 0 minus 240, that is negative 240 J, okay? Negative 320 minus 0, that is negative 320 K, negative 320 K millimeters. That's the position vector. The next step is for you to find the magnitude of the position vector. This magnitude will help you find the unit vector, okay? So what is the magnitude of AC? What is the magnitude of AC? So we're going to say negative 960 squared plus negative 240 squared plus negative 320 squared. Okay? Can someone punch for me the magnitude of AC? Okay? What's it? Okay. Like this? Okay? 140 millimeters. Okay? So the next step, apart from finding the magnitude, we are also going to find the unit vector. The unit vector of AC, okay, is equal to our AC over the magnitude of AC, which is equal to negative 960 over 1040 I, okay, minus 240 over 1040 J, okay, minus 320 over 1040 K. That is the unit vector of AC. Any question? Anyone who is behind? All right. Someone is behind. So the next step is for us to express, okay, the force in AC as a Cartesian coordinate. Meaning, we're going to multiply force AC is equal to force AC multiplied with unit vector AC. For this case, force AC tatuishime. So tukaweka force AC multiplied with unit vector AC. Can you reduce this number for me? Negative 960 divided by 1040. 0.9 what? 923. I, okay? Minus 240 over 1040. 0.231 J, okay? Negative 320 over 1040. 320 divided by 1040. 0.308 K Newton, exactly. So we have also found the force AC and force AB. So you can copy sharp sharp. Then copy. All right. Let me just write this. All right. Now you go to the other position vector, which is the AD. Okay. Our AD is equal to D minus A. Our AD is equal to what? D minus A. We're going to subtract D and A. Okay. So therefore, our AD is equal to D minus A, which is 0 minus 960. That is negative 960 I. Okay. 960 minus 240. 960 minus 240. What? What? 720. Okay. Positive 720. Positive 720 J. Okay. Negative 220 minus 0. That is negative 220 K meters. Okay. So the next step here is for us to find the magnitude of AD. Okay. Can you tell me the magnitude of AD? You can punch and tell me the magnitude of AD. Okay. What's it? Okay, 1,000. 1,220. Right. Like this? All right. 1,220 millimeters. So apart from you finding the magnitude, you also need to find the unit vector of AD. The unit vector of AD is equal to negative 960 over 1,220 I plus 720 over 220 J minus 220 over 1,220. Okay? Okay. Like this. So the next step here, you're going to express force AD. You're going to express force AD as a what? As a Cartesian what? Coordinates. Okay? How do you express it? By multiplying force with a unit vector. Okay? Force AD is equal to force AD multiplied with unit vector AD. Okay? What is our force AD? We don't know. You just have to write it. Force AD multiplied with the unit vector AD. Okay? You can reduce this number for me. Negative 960 over 1220. Okay? 960 divided by 1220. Okay? 0.787. Okay? I plus C. 720 over this one. Okay? 0.5 what? 0.5 what? Okay? 9J minus C. 220 over that one. 0.180 K. Okay? That's all. That is for C, A, D. So we're done correcting the points. We're done correct. So you can copy short. Okay, I hope you're done. Okay. So guys, let us read the question again. So as you can see, they have said, knowing that force Q is equal to 0. So you must ignore this. It's playing no role in here. Okay. And also, the tension in cable AD. The tension in cable AD is what? The tension in cable AD is what? 305 Newton. So for this case, we're going to multiply everything with 305. 305 multiplied with 0.787 I plus 0.59 J minus 0.18 K. Okay? Can you multiply this? 305 multiplied with this one. That is our first AD. Okay? 305 multiplied with that one. Okay? Exactly. Negative 240. Okay? I. Okay? 305 multiplied with 0.59. What's it? Okay? 180 J. Okay? Minus 305 multiplied with 0.18. What's it? 55 V? Alright. 55 K. Okay? Newtons. Okay? So for this one now, you should be going because we are given force AD. Okay? So therefore, force AD is equal to that one, negative 240 I, okay, plus 180 J, okay, minus 55 K Newton. Okay? Any question, guys, so far? Any question? Anyone is behind? We explain. Okay? So these things are very simple as long as you're following math tips. Okay? Good definitions, 25 marks. Okay? So these questions are most likely to come. Remember, question is higher palette. Okay? All right. Okay. So the next step for this question, okay? So as you can see, there is also, these are forces, okay? These are forces in form of formal coordinate, not the x, y, and z. So as you can see, P is also a force, okay? P is also a what? A force. So also going to put P here. Therefore, P is equal to, okay? P, as you can see, P is a force in what coordinate? In the x. P is a force in the what? In the x. So it's only going to have P I. We're going to put Pi. If it was in the z or in the y, we would have put J or K. But for this case, P is a force going through the direction of x. So we're going to put force Pi in the x. Okay. So the next step after finding the forces, the Cartesian forces, we're also going to apply this step. Okay. Equation. Okay. Equations of equilibrium. Okay. Equations of equilibrium. Okay. Yeah. We're also going to apply equation of equilibrium. For this case, we have reached this step because we have too many unknowns. We have too many unknowns. That's why we have included this step. Okay. Equation of equilibrium. We're going to find that the first step, we're going to add, okay, the sum of the forces in the x. So as you can see, there is sum of the forces in the x is equal to 0. Number 2, the sum of the forces in the y is equal to 0. Number 3, the sum of the forces in the z is equal to 0. Now for this case, okay, we cannot start with the sum of the forces in the x because we have too many unknown. We don't know P. P is in the x, okay? We don't know this one, we don't know this one. So maybe we can start from y, the sum of the forces in the y, okay? So it's going to be the sum of the forces in the y is equal to 0, meaning we are going to add all the forces in the y and equate them to 0. I hope you have gotten the point where I started with y. We cannot start with x because let's solve it. Toraba stack up a point up. Some of the values are missing. So we are going to start with some of the forces in the y. Okay? So when talk about some of the forces in the y, mean we are going to add all the forces in the y and equate them to 0. As you can see, these are forces in the y. These are forces in the y. So the first one we have negative 0.226 force AB. Okay. The other one we have negative 0.231 for CAC. Okay. The last one we have a positive 180 for what? For CAD. So this one is going to be our first equation. That one is going to be our what? Our first equation. Anyone who's behind so far? Yes. Okay. We choose the sum of the forces in the y as our first equation because we cannot start with x because we have too many unknowns. Okay. We don't have force AB. We don't have force AC. Okay. We will be stuck at some point. Okay. But we prefer to start with some of the forces in the y and in the z so that we can come up with the equations. We can come up with what? Equations to help us find this force, this missing force. Okay? So for this case, force 8, we cannot put this one because as you can see, force 8 we already found it. We multiplied with a certain number here. So force 8 it's going to be independent like that one. We're not going to put it force 8, but this one, they did not have AMA forces in front. So that's why you have applied the force AB and force 8D. Okay? So we are going to find these missing forces. Okay? Using this equation. Okay? So the next step here, we're going to say the sum of the forces in the z is equal to 0. The sum of the forces in the z is equal to 0, meaning we are going to add all the forces in the z-axis and equate them to 0. Okay. What force was here? Okay. Yes, Mr. Yeah. Okay. Yeah. In the x. Exactly. 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 Okay. So what force was here? Under force AB, and this part, it was what? Okay. This one, we found it. This one, force AB, in the X, in the Y, and in the Z. What was in the Z? Positive what? 3585. K. Yeah, IJK. Okay. So we are saying the sum of the forces in the Z is equal to 0. Meaning we are going to add all the forces in the Z and equate them to 0. Okay. Okay. So it's going to be 0.3585 force AB, okay, minus 0.3080 force AC, and this force is going to be negative 55, okay, which is equal to 0, okay. So these forces These two equations can be solved simultaneously, okay? So negative 0.226 force AB minus 0.231 force AC is equal to this 180. When it goes to the other side, it's going to be negative 180. Also this one, 0.3585 force AB minus 0.308 force AC is equal to 55. When it goes to the other side, it is going to be positive 55. Therefore, force AB is equal to and force AC is equal to. So you can solve this equation using your calculator. Okay? So you can solve those equations using your calculators. Okay? Yeah, sure. Okay. Yeah, force AB. Yeah, you want to ask exactly. On a calculator. Okay. What type of calculator do you have? Casual? Or that one? So you have to place shift, then you go on equations. I don't, you wanted to ask how to find this on a calculator. Okay. And what? Force AB. Okay. 447.083. Okay. 341.81 5 newtons. Okay. So means we have found the forces. So you can copy. You can copy up to everyone has found the answer. That one. You have found it. All right. Okay. So we can proceed. We can proceed. So our next step, we're going to apply the other equation of equilibrium, okay? The last equation, which is the sum of the forces now in the x is equal to 0. This one is solvable because we have at least found the two stuff that was unknown. Now they are known, okay? So now we can find the forces in the x, okay? So you can tell me the forces in the x, okay? The sum of the forces in the x, okay? What? Negative 0.906 force what? Force AB, okay? The other one force in the x, negative 0.923 force what? AC, the last one, the other one, negative 240, the last one, what? Exactly, positive P, which we are looking for, okay? So now, on these two forces, you're going to do the replacement, okay? Therefore, it's going to be negative 0.906. Where there is force AB, you're going to replace with what you have found, which is going to be 447.083 minus 0.923. Force AC, you're going to replace with that one, 341.815 minus 240, okay, plus P, okay? You can help me to punch this. Okay, what is negative 0.90 multiplied with that one? Okay, negative 0.906 multiplied with 447.083. Okay, negative 405, that's all, 0.06 minus 0.923 multiplied with 341.815. Okay, yes, yes. The what? To 0, okay? Exactly. Equation of equilibrium is supposed to equate to 0. Exactly. Okay? Yeah. What is 0.923 multiplied with that one? Okay? Negative 315.5. Okay? Minus 240 is equal to, thing up to the other side is going to be negative P. Can you do the math here? What? So it's going to be negative 960 is equal to negative P. So negative and negative will cancel out. Therefore, P is equal to 960 Newton. 960.6 exact. 0.6 Newtons. So means you are done. Okay? So this question is yellow wrong. That's why they carry 25 marks. Okay? So in one of these practice question, made by Sawakafunyamu Yabiri. So at least you can get at least 50. Okay, you cannot fail statistics. At least you can get 50 from just passing from a practice question. Okay? At least 50 marks. Then the other 50 marks will come from other books, from other ideas. So you can copy and go to the other question. You done copying? Right.